called finding the structural response of materials. What we'll be doing today is testing of 3D printed samples on the tensile testing machine. Right before you, you see a Shimatsu AGS-X 100 kilonewton ultimate tensile testing machine. So it can perform testing in the range of force from 0 to 100 kilonewtons. This machine has a crosshead with an up and down movement. To the crosshead you have connected the upper jog. On below you have a lower jog. This is the elements where you place the specimen for testing. The specimen is folded with plates which are inserted in the lower jog and in the upper jog. So, on the crosshead, connected up, you have a load cell that is a sensor measuring a force during the testing. So, this load cell with few elements here is connected with this here element on the top with a cylinder holding this upper jog. So, first what you have to do after switching on your device, you have to click on System to calibrate the machine. So here a machine asks us to calibrate the device. So I'm pressing Start. It will calibrate force in a short while. So I'm pressing Start again. And now it performs calibration of force. So the force goes to the maximum value and slowly decreasing to 0. That's when the calibration will stop. The control of the device you can perform on this panel installed on the machine and on the computer from the licensed software as well. After calibrating a force on this here machine, we uncheck System by pressing a Test button. So the main commands on this here device are through this here digits: test, method, file, and system. When you want to load a method file, I'll show you what that means, or a test file, you can upload them using this here buttons and choosing on this here disk. Using this here disk, you choose a file you want to use for your testing. So we have clicked a test button, so we are about ready to perform testing. On the panel you see the calculated force and displacement on this here machine. So first things what we do here is that we apply force, and specimen has some pathway. It displaces in millimeters. So this is what we perform, and the stress and strain values which we need for the testing are calculated from the dimension of the specimen. This is about the upper commands on this here panel. Next, we have main tools for this test, that is start and stop button. With start you perform an operation, with stop you cancel it. Then we have force 0 hold, that is for dispersing the force value from during the testing of a specimen. you have a return button, and to move up and down the crosshead, or better to say, to move a upper jog, this is what you do. Just focus on the panel. So I activate a jog with this on-off button, and now jog can move up or down. But you see on the panel here, I am slowly moving a upper jog, but with an increment of a 100th part of a millimeter. If I want to move a jog slightly faster, I can use this disc for down and up movement, or I can press this high speed button, from which I move a upper jog up, now I'm pausing, or down. In using this jog movement, you insert a specimen into the jogs there. So I'll deactivate high speed, and I'm deactivating a jog. So when you're finished, you have to deactivate a jog on-off button to start your testing. Then you have some options about a shape of your jogs, which ones will you use, and so on. Before the testing, if you want to zero value of force and displacement, you have this here small option to zero those values. Just to point out that when a specimen is loaded and you have a certain force on the jogs, it is for best consideration to have this option to force zero hold. That's how you disperse the force from the jogs. If the force is at low value, like few newtons, you press zero force, and now you have a zero value of force. And with zeroing the stroke value is at zero value. For the tensile testing, we use a ISO 527-2 standard for tensile testing of specimens that are made of extruded plastics. So that standard suggests 5 same specimens for testing. Here we have standard PLA material with 100% infill of the plastic. All 5 are the same, and after testing 5 samples, we take an average value, and that is a value we use as a referent for the tested material. So, next thing we do is that we insert first specimen on jogs. These jogs contain plates which press the lower and upper end of a specimen, and that is how a machine holds the specimen. The lower jog does not move, so the lower end will be fixed, but the upper jog for tensile testing goes up and makes tension on the middle section of the specimen. So holding the upper end and pushing it up, you'll have, in ideal case, a tension in the middle, and that is where you will have a failure, or to say breaking of a specimen. So the plates are inserted into jogs. There are different plates for different thicknesses of the specimen. They have an increment of about 7 millimeters. So this here specimen has a thickness of 4 millimeters. So we will use plates for 0 to 7 millimeters thickness of specimens. Here we have 7 to 14, and also we have plates for testing of materials that are from 14 to 21 millimeters. So the inserted plates are for thickness of 0 to 7 millimeter of specimens. So you have this here lever to open in the clockwise movement of plates. Then you have the closing in the counterclockwise movement. So first I will insert the lower end on the bottom jog. So I am placing a specimen. You have certain lines here which show the correct positioning of the specimen. So I am inserting a specimen right in the center of the plate using the pointers inserted in the plate. So I am checking if the specimen stays firm. So then I'm closing with the counterclockwise movement of this lever. So I'm now closing a lower jog. Specimen won't go nowhere. Now I'll have to lower the upper jog just a little. Now I'm closing a jog movement. The specimen is at the correct position. So now I am closing a upper jog. This is how a specimen is placed onto a tensile testing machine. After inserting the specimen, we have a reading of about 2 newtons of force, and we have a minus value of displacement. What we need at the first period of the testing, we need to set all the values to 0. So for the force, I'm force 0 holding it to have as close as possible to 0 value. I'm stopping now a force 0 hold option, and now we have about 1 newton of force. So using a 0 force option, I'm zeroing a force. Of course you have some reading due to a weight of the jogs and so on. Now for a value of displacement, I'm setting it with a 0 stroke movement to 0. Stop. A specimen is loaded on the machine, so the next thing what we'll do is to activate a software for defining the parameters of testing. The licensed software for this machine is called Trapezium X. I'm opening it, and this is how a user interface of this program looks like. This is a base screen. You have a readings of force and stroke here. So we see that the force is about few newtons and the stroke stays at 0 where we placed it. That is due to the weight of the upper jog. Now you have first how this program operates. You have a method file on which it performs a testing. So first what you have to create is a method file And after defining a method file, you are then activating a test file which performs on the basis of the parameters set in the method file. So at Trapezium X we can open or select test file, or to create, or if we already created one, we just open a test method. So we don't have any file for this testing. So first what we're about to do is to create a new method by clicking the right option. Now we get a new window with 7 cards. From left to right we'll set all the needed parameters for the testing. When we finish, we have the buttons on the left side where we save a method file, test with the created method file, to finish or to cancel. So first we have a system card. This is where we define the units in which we are working and the type of the testing. So first, what the program asks us is the test mode. So the options here are single, where we want to perform a tensile or compression testing, then cycle, when we are applying a dynamic load, and control, when we play with the parameters and want to see maybe some fatigue, and then tensile testing. It's a open mode here with which we define any kind of testing or combination of testing. So what we are performing today is a